أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Wireless channel can be considered as a medium between two endpoints of a communication system. One endpoint can be considered as a transmitter that transmit or sends the signal that will be propagated throughout the wireless medium. The transmitted signal will be received by the other endpoint or the receiver. There is no wired or physical connection between these two endpoints in a wireless channel. In this unit, we will generally discuss about channel modeling for wireless communication system. First of all, we discuss about what is wireless channels and why we need for the channel modeling and what channel parameter we estimated through this model, which is used for the wireless communication system. Wireless channel refer to the medium through which wireless signal propagates between the transmitter and receiver in a wireless communication, as we discussed in the previous slide. It serves as a physical pathway for transferring information wirelessly, such as in cellular network, Wi-Fi, Bluetooth, satellite communication, and many other type of wireless communication technologies. In wireless channel, signals are typically transmitted through the air, to the air or free space, but they can also propagate through other medium like water or wall in certain applications. Wireless channel introduces various characteristics and challenges that differ from those of wired communication channels. Some key aspect of wireless channel includes path loss. Path loss generally can be referred to the attenuation of the transmitted signal strength in terms of power as it propagates through the space. It is influenced by many factors such as distance, frequency of the transmitted signal, and obstacle available present in the propagation path. As the distance between the transmitter and receiver increase, the signal power generally decrease due to the inherent nature of spreading and absorption. Path loss is a very critical factor in determining the coverage area and link budget of the wireless system. Similarly, fading is basically the fluctuation of the signal strength over time due to multi-path propagation. In wireless channel, signal can take multiple paths and arrive at receiver with many different delays and amplitude due to reflection, diffraction, and scattering. This causes constructive as well as destructive interference, but overall resulting in the fading effects. Fading can be categorized into two types, such as fast fading, which occur uh, over short period of time, a short time scale, and slow fading, which occurs very long period of time, a long time scale. Similarly, multipath propagation refer to the phenomena where multiple copies of the transmitted signal, a message, arrived at the receiver with different delays, amplitudes. And they are most of the time they are random in nature. It is caused by the reflection, diffraction, and scattering of the signal by object and the environment. Multi-path propagation can result in irreversible interference in the digital communication system, which can degrade the quality of the received signal. Similarly, shadowing, also known as a long normal fading or large-scale fading, in which additional attenuation of the transmitted signal caused by the obstacle or obstruction in the propagation path. Introduce long-term variation in signal strength due to changes in the environment, such as building, terrain, or vegetation. Shadowing is typically modeled as a long normal distribution and is an important factor in the link budget calculation and coverage plan. Similarly, interference in wireless channel interferences arises from many other sources of transmission that share the same frequency spectrum or may not share the same frequency spectrum, but channel spectrum also. Interference can degrade the quality and reliability of wireless communication systems. It can be caused by co-channel interferences from other users or system operating in the same frequency band or adjacent channel interference from signal in nearby frequency bands. Purpose of channel modeling is to understand and predict how the transmitted signal will be affected by the various factors in the channel, such as noise, interferences, and distortion. By modeling the channel, engineer can design communication systems that are highly optimized for the specific characteristic and given limitation of the channel. Channel modeling involves many key parameters, the key aspects which play a very vital role, not only for the design, but also maintaining and improving the efficiency of the wireless communication system. Most important is signal propagation. This aspect deals with how the signal propagates through the channel. In wireless communication, for example, it considers factors like path loss, multipath fading, and shadowing. Path loss refers to the attenuation of the signal strength as it travels through space, while multipath fading accounts for the variation caused by the reflection, diffraction, and scattering. Shadowing refers to the additional attenuation caused by the obstacle in the propagation path. Similarly, noise and interference. Noise refers to the unwanted signal present in the channel. It can also present in the transmitter and receiver itself. That can corrupt the transmitted information. Interference, on the other hand, arises from many other sources of transmission that share the same channel. Channel modeling take into account the statistical properties of the noise and interferences, such as their power spectrum density, to assess their impact on the communication systems. So channel capacity is another very important channel parameter, which is used for modeling of the channel modeling. Channel capacity represents the maximum achievable data rates over a given channel, subject to the constraint imposed by the noise and other impairments. Channel modeling helps in estimating the capacity of the channel, while it is very fundamental measure of its performance. It allows engineer to determine the maximum achievable data rates and design communication speed to approach this limit. Similarly, error probability. Channel modeling also involves analyzing the error probability of the transmitted information by considering the characteristic of a channel, such as noise and interferences. It's possible to estimate the probability of the bit error or symbol errors through the help of channel model. This information is very crucial for designing error correction and error detection technique to improve the overall reliability of the wireless communication system. Channel modeling can be performed using analytical techniques, computer simulation, or a combination of these two techniques. Analytical model often make simplifying assumption to drive mathematical expression that describe the channel behavior. Simulation, on the other hand, involve generating synthetic data and propagating it through the model channel to observe its overall effect. Overall, channel modeling play a vital role in the design, analysis, and optimization of communication system, enabling engineers to understand how different factors affects the performance and reliability of a wireless communication system. From channel modeling, several parameters can be calculated or derived. The most important is channel capacity. Channel capacity quantifies the maximum achievable data rate over a given channel. Channel modeling can be used to estimate the channel capacity based on parameters like signal to noise ratio, bandwidth, and channel characteristics. Capacity calculate helps to determine the maximum data rate that can be reliably transmitted over the channel. Similarly, signal to noise ratio is another fundamental parameter that characterize the quality of the received signal. Channel modeling can help estimate the SNR by considering factors such as path loss, noise power, and interference level. Signal to noise ratio calculation are essential for evaluating the system performance and determining the achievable data. Interference parameters channel modeling can improve insight into interference level by considering factors such as co-channel interference from other users or system operating in the same frequency band or adjust channel interference from signals in nearby frequency band. Interference parameters helps to evaluate the system susceptibility to interference and aid in interference management strategies. Similarly, diversity techniques such as spatial diversity or frequency diversity are used to combat fading and improve system performance. Channel modeling can quantify the diversity gain achieved by employing several techniques. It helps in understanding the benefit of diversity and optimizing the system design. Similarly, channel correlation is another parameter which is used for to estimate through channel modeling. Because channel modeling can provide correlation parameters that describe the spatial or temporal correlation between different channel realized. Channel correlation overall affects the performance of multiple antenna system and diversity technique. Understanding channel correlation helps to optimize the system parameters and enhance performance. All these parameters obtained from channel modeling are very important for wireless communication design, performance analysis, and optimization in wireless communication systems. They provide valuable insight into the channel behavior, enabling engineers to make informed decisions regarding modulation scheme, coding techniques, power control, antenna configuration, and resources allocation to achieve reliable and efficient wireless communication.